Hey guys, so we've been talking about diffusion and how particles will move through space or solution, like food coloring, right? You put food coloring in one side of a container, it's going to move or spread out to the other parts of the container. So we're going to talk about a few new things. We're going to talk about a few new words, which are membrane and this idea of being semi-permeable. Okay, so a membrane, if we're talking about a cell, this is the outside of the cell. This would be the cell membrane. Okay, we can think about it like the skin. That would be our membrane for us. Other things that we could think of are something a little bit more day to day, like the idea of a tea bag, right? Looks something like that. This is a tea bag. This is also a membrane. It's the membrane of the tea bag. So let's define a membrane. Membrane as is a boundary, which is usually on the outside, right? It's usually on the outside of something or dividing two things, which we'll see next, is a boundary that allows some things through, but not others. Okay, so in the case of the tea bag, the water, right, H2O, is going to be able to go through and come out, right? That's how you get your tea steeped. But the tea itself, the leaves, stay inside the bag the whole time. Okay, so I can show you that here. I have just some cheesecloth and some rocks, right? This cheesecloth is a membrane, right? It'll allow some things to get through and some things not. Right now it's holding some fish rocks, okay? And you can see that it's not allowing the rocks to go through, so it is stopping the rocks. Okay, the rocks cannot penetrate or permeate this membrane, but you can imagine that if I poured water through this, it would just go straight through, or even just the air in the room is going through this membrane, okay? So you can see the little stitching there. Water would easily go through, air easily goes through. Smaller, tinier rocks like sand would probably go through, but these larger rocks are getting caught up. Okay, that's a membrane. So you can imagine the same for a tea bag. And at the top here, a cell membrane for a biology. A cell membrane will let in food and water, but it won't let in other things. Okay, so semi-permeable, right? New word, semi-permeable means some or partly maybe. And then permeable, let's divide the two words here. Permeable, it's one word, but I just wanted to show you guys the two roots. So semi meaning some, partly, or partly permeable meaning gets through. So if you permeate something, that means you can go through it. So some gets through, or part of it gets through. What we're going to talk about as well is this idea of selectively permeable. Okay, which is the same idea. Some will get through and some won't, but this idea of selectively, this only happens in living things. Sorry, the organism, like us or a cat or a cell or plant. So we can imagine something selectively permeable, like in our digestive system. So if you eat something, it'll go through your stomach into your intestines, and your intestines will pull out all of the good stuff and will leave the rest. So it'll choose what it wants to allow through into your blood as nutrients, and it will uh, just let the rest pass as waste, right? So it only takes in what it wants. And the same thing goes for, let's say, like a plant root, right? If we have a nice little flower, and then as soon as it gets to the ground, right, the roots they choose mostly. I'm not saying that they have a discussion and have a brain, but they choose, we'll say, to bring in, right, H2O and some of the nutrients that it needs. Okay, so the roots choose, right? That's selective. Only living things get to select. Okay, this cloth is semi-permeable. It lets some things through, some things not, but it's not selectively permeable. Okay, and another distinction here, semi-permeable is usually has to do with size. Okay, has to do with the size of the object. So here, the rock particles are too big to get through. Water would go through easily. Okay, selectively permeable, size doesn't matter so much. Okay, so next we're going to take a look at some, we're going to put a membrane now in our dish or our container. So if we can imagine that there's a membrane down the middle here, and it's going to be selectively permeable. So imagine that we have squares and triangles, and right now we have an area of high concentration, an area of low concentration over here, right? Same thing as the food coloring. We know that they're going to spread out. But let's say that the membrane will allow triangles through. Okay, so the triangles can go all the way through. When the square comes up and gets to the membrane, it's not going to be able to get through, so it's going to get blocked. So these can travel all the way through. These ones are going to get to here, and then they're going to get stopped. Okay, so they're still going to diffuse. So what's going to happen is we're going to look something like this, where it is, right? Maybe we'll have a triangle here and a triangle here. We'll have them diffused, right? They'll spread out as much as they can. And then I'll let you guys think about what's going to happen to the squares. Okay, so that's a question coming up in the next little bit here. So where the square is going to end up, I think that's a good question. Next, I want to talk about a few new words, one being equilibrium. Okay, the root word here is equal, or we can think of balance. Okay, so notice that there's an equal amount of triangles on either side. There's a balance of triangles on either side. We can say that this is at equilibrium. Okay, we found or reached equilibrium is what we would say. Okay. So we'll try to use those words coming up. Try the next couple questions. think about the membrane, what's going to go through, what's not. Are they still going to diffuse? What does equilibrium look like when they don't get through the membrane? What does equilibrium look like when they do get through the membrane? Okay, so give those a shot. Cheers, guys.